Okay, so quiz 7. Quiz 7 here. So, mechanism, deprotection of cyclic acetal. This is the one where in acidic conditions, right? First steps are given: proton transfer, elimination, addition, proton transfer, elimination, proton transfer. So acidic conditions, so it has to always have a plus charge. Should not have any minus charges in this one. So the first step is protonation. Next step is elimination, right? So that made this a better leaving group. What we're going to end up doing, this oxygen ends up being this oxygen. A diol means diol, a di-alcohol. The elimination, water adds in, right? Adds in, we break that pi bond. One people kind of get goofed up on here is we need to break this bond. We need to get the diol released. We already got one diol part released. Now release the other part. To do that, we need to do a proton transfer to make this a better leaving group. So do the proton transfer here. The oxygen is also bonded to the same carbon. Do elimination to break that off, right? Get to our ketone. Proton transfer again. Again, always remember the H falls off, right? H never takes electrons. It gets us to the diol, and we regenerate our catalyst in that last step. Bunch of things to think about. Wherever you start electrons at, that ends up having a plus charge. Why do we do proton transfers? To make things better leaving groups. All right, so question 2. Now we're in basic conditions, right? So the first step for this one, when it's basic conditions, is addition. We have an S minus, right? For acidic, it's protonation. For basic and neutral, it's always addition. Negative, if you have charges, they react first. Negative charge adds in, right? Make a tetrahedral intermediate. Electrons come down, kick out, right? Still, we're in negative charges. Elimination. Final proton transfer is regenerating the catalyst. We take the hydrogen from the sulfur. Negative charge there. Biggest things, remembering balancing your charges. This is the most reactive species, the S minus. That's what needs to react first.